Hello students, myself Dr. Khushboo Verma, and today I am going to discuss about inverse Laplace transformation. Inverse Laplace transformation. All those formula which you use to find Laplace transformation is also helpful to find the inverse Laplace transformation. Like if Laplace transformation of 1 is 1 by s, then inverse Laplace transformation of 1 by s is also 1. Laplace transformation of e raised to power at is equals to 1 by s minus a, then inverse of Laplace transformation of 1 upon s minus a is equals to e raised to power at. That means all those formula which you have, which you see in Laplace transformation is also helpful to find the inverse Laplace transformation. Now to find the inverse Laplace transformation, the first step is you have to convert the given function into the part so that the inverse Laplace transformation easily can be detected. Now the method is, first is partial fraction. With the help of partial fraction you have to separate this function into two parts. Now operate L inverse on both parts separately. The first part, inverse of this Laplace transformation 1 upon s minus a with the formula is e raised to power t, and inverse Laplace transformation of 1 upon s plus a with the help of the formula is e raised to power minus t. The next method is you have to you can solve it manually. Our aim is only to convert the function into the form so that the inverse Laplace transformation is easily detected with the help of the formula. Now separate all the part. S cube plus 2s upon s cube plus 3 upon s cube, and this can be written as 1 by s plus 2 into L inverse of 1 by s square plus 3 into L inverse of 1 by s cube, and this is equals to inverse Laplace transformation of 1 by s with the help of the formula is 1 plus 2 into inverse Laplace transformation of 1 by s square is gamma n plus 1 upon s raised to power n plus 1 for Tn. Then 1 upon s square is what? That means t upon gamma 2. That means factorial 1, that is equals to 1 also. Now 3 into 1 upon s cube is what? For this n is equals to 2, that means t square upon factorial 2. Now after solving we get 2t plus 3 by 2 t square. That is the answer. Next question is to find the Laplace inverse of 2 upon s into s square plus 4. As we said earlier, all those formula which you use to find the Laplace transformation is also helpful for to get the inverse Laplace transformation. See, if Laplace transformation of ft is equals to fs, then you see the Laplace transformation of integral is what? The Laplace transformation of 0 to t ft dt is equals to fs upon s. Now operate L inverse on both sides. You will get, if inverse Laplace transformation of fs is equals to ft, then inverse Laplace transformation of fs upon s is equals to 0 to t ft dt. Okay, now apply this formula to solve this question, because here we see the s in denominator. L inverse is 2 upon s square plus 4 upon s. Now if we compare this with this formula, then we get fs is equals to 2 upon s square plus 4. If fs is equals to this, then what was the ft is here? That is sine 2t. Okay, if ft is equals to sine 2t, then this implies Laplace transformation of fs upon s, that is inverse Laplace transformation of 2 upon sine square plus 4 upon s is equals to, with the help of this formula, is equals to 0 to t sine 2t dt. Okay, this implies L inverse of 2 upon s into s square plus 4 is equals to integrate this and you will get the answer. Okay. So with the help of the partial fraction manually or with the help of the earlier method which you learn to get the Laplace transformation, also useful to find the inverse Laplace transformation. One other method is that is very important, that is the convolution theorem to get the inverse Laplace transformation. The statement of this theorem is also very important. What is the statement of this? If inverse transformation of fs is equals to ft and inverse transformation of gs is equals to gt, then inverse transformation of multiplication of fs and gs is equals to f convolution g. The value of the convolution is equals to 0 to t fu g t minus u du. Okay. Integration from 0 to t fu g t minus u into du. That means if we have a function like fs into gs and we want to inverse Laplace transformation of those function, this will equals to integration 0 to t fu g t minus u du. After that we will get the function in form of t because integration is taken with respect to u only. Okay. Let now solve the question. First question is L inverse of s square upon s square plus a square, s square plus b square. All those questions in which we are able to find fs and gs and whose inverse transformation easily detected, that means ft and gt is also known, is useful with the help of this convolution theorem. Okay. Now see this question. First of all, first step, you have to separate it into fs and gs part. Let fs is equals to s upon s square plus a square and s upon s square plus b square. This part is fs and this part is gs. If you take this s is here, that means s square upon s square plus a square as fs and 1 upon s square plus b square as gs, then inverse transformation of this function, you can convert it as you will get the inverse transformation of the gs in that case, but inverse transformation of fs in that case is not easily detectable. Okay. That's why you have to choose fs and gs like this so that the inverse transformation is easily convertible. Now if fs is equals to this, then ft is what? Because this is the inverse transformation of cos 80. Now if gs is this, the inverse transformation of this is cos bt. Now Laplace inverse transformation, multiplication of this fs into gs is equals to, with the rule 0 to t, ft can be written as fu like cos au and gt can be written as gt minus u. That means each t can be replaced by t minus u. Then cos bt can be rewritten as cos b into t minus u du. Now simple, integrate it. This is a problem of cos a cos b. Cos a cos b is equals to 1 by 2 into cos a plus b plus cos a minus b. Change it and integrate it with respect to u and you will get the answer. Now next question, inverse Laplace transformation of s square upon s square plus a square whole square. First step, you have to find what is fs here and what is gs here, whose inverse transformation is easily detectable. Now see, let fs is equals to s upon s square plus a square into s upon s square plus a square gs. Here is it's if fs is this, then ft is what? Cos 80 and gs is equals to this, then gt is what? Again cos 80. In this case, if inverse of this transformation, we can solve this by partial fraction also, but with the help of convolution theorem we have to separate it into fs into gs. For this, fs is equals to 1 upon s plus a and 1 upon s plus b. For this question, 1 upon s into 1 upon s square plus 4. Okay. Now come to the next very important method, that is the transformation of derivative. Transformation of derivative. Transformation of derivative is if Laplace transformation of ft is equals to fs, then Laplace transformation of f dash t is equals to sfs minus f0. How? Let's see. If Laplace transform, we have to find Laplace transformation of the derivative. By the rule of the Laplace transformation, this can be convertible as 0 to infinity e raised to power minus mt f dash t dt. Then now integrate it, you will get this e raised to power minus st into ft 0 to infinity minus 0 to infinity minus s into e raised to power minus st ft dt. After solving this, you will get Laplace transformation of the derivative is equals to sfs minus f0. Equation number 1. Now similarly, Laplace transformation of second derivative is what? Manually 0 to infinity e raised to power minus st into f double dash t dt. Okay, now integrate it, first function into second function e raised to power minus st, differentiate this function, that is f dash t 0 to infinity limit. Now minus 0 to infinity minus s into e raised to power minus st f dash t dt. After solving this, you will get minus f dash 0 plus s into 0 to infinity e raised to power minus st f dash t dt. The value of this can be written from equation number 1, and you will get s square fs minus s f0 minus f dash 0. Similarly, you can find Laplace transformation of triple dash t, triple derivative of ft. Every time you need not to integrate like this. There is a pattern to write the Laplace transformation of first derivative and Laplace transformation of second derivative. What is the pattern is, here you can see in second derivative the power of s is in decreasing order. For second derivative, you can start from s square, then 1, then s raised to power 0. Okay, that is power of s is in decreasing order, and order of the f0 is, the order of the derivative of f0 is in increasing order. Okay, now based on this pattern, what is the Laplace transformation of this third derivative? That means you can start from s cube, s square, s, and finally s raised to power 0. Okay, and coefficient of highest power is always be f of s. Okay, and then start with f0, f dash 0, and f double dash 0. Similarly, fourth order, s4, s cube, s square, s, and finally s raised to power 0. And you have to start from fs, f0, f dash 0, double dash 0, and f triple dash 0. Fourth order, 1, 2, 3, 4, 5. Fifth order, s raised to power 5, s raised to power 5, s raised to power 4, cube, square, 1, and then s raised to power 0. fs, f0, f dash 0, double dash 0, 1, 2, 3, triple dash 0, and 1, 2, 3, 4, 0. Okay, these are the Laplace transformation, and this is very useful to solve the differential equation with given initial condition. Now what is let me take a question like third derivative of y plus 2y double dash minus y dash plus 2y is equals to 0, and given the initial condition is y0 and y dash 0 is equals to 0 and y double dash 0 is equals to 6 here. Suppose let ys is equals to y bar, or Laplace transformation of Laplace transformation of y or ys is taken as y bar here. Okay, now operate Laplace transformation in this equation on both sides. Then what will we get? Laplace transformation of y triple bar 2 into Laplace transformation of y double dash minus Laplace transformation of y dash minus 2 into Laplace transformation of y is equals to Laplace transformation of 0. Laplace transformation of y, triple derivative of y, can be rewritten as triple derivative. That means you have to start from s cube, s square, s, and s raised to power 0, and multiplied by ys is taken as y bar here, then y bar minus s square y0 y dash 0 and y double 0. Okay, this is the value of Laplace transformation of y triple bar. Now 2 into Laplace transformation of second derivative of y, 2 into Laplace transformation of second derivative y. Second derivative, that means you have to start from s square minus s and then s raised to power 0 and multiply by y bar into y0 and y dash 0. Similarly, Laplace transformation of first derivative is s into y bar minus y0, and last Laplace transformation of y is written as y bar only, and Laplace transformation of 0 is equals to 0. Okay, now after putting, now put the value of the initial condition y dash and y double dash y0 and y dash is equals to 0 and y double dash 0 is equals to 6 here, and after equating this you will get s cube y plus 2s square minus s minus 2 into y bar is no, this y bar is not here. S cube plus 2s square minus s plus minus 2 into y bar is equals to 6. Now divide this, y bar is equals to 6 upon this. You have to find y bar is equals to 6 upon this. After factorization you will get 6 upon s minus 1, s plus 1 and s plus 2. Now with the help of the partial fraction you can convert this function separately like this: 1 upon s minus n minus 3 upon s plus 1 plus 2 upon 2 into 1 upon s plus 2. This is equals to y bar. Y bar is what? Earlier you mentioned that y bar is equals to L y. Now operating L inverse on both sides, you will get y on left side and L inverse of 1 upon s minus 1 minus 3 into L inverse upon 1 upon s plus 1 plus 2 into L inverse into 1 upon s plus 2. Inverse Laplace transformation of this is e raised to power t. Inverse Laplace transformation of this is e raised to power minus t. Inverse Laplace transformation of this is e raised to power minus 2t. And equate this, you will get y is equals to e raised to power t plus 2 into e raised to power minus 2t minus 3 e raised to power minus t. At this step, you have to apply either convolution method or partial fraction method or manual method, and you have to get the inverse Laplace transformation of the right hand side function so that you will get the value of y, because in differential equation the unknown quantity is y here and we have to solve this. We have to find this value y with the help of Laplace transformation. Okay. Similarly, we can solve simultaneous differential equation also with the help of this Laplace transformation. How? Let's see one example for this. Dx by dt plus 5x minus 2y is equals to t, and dy by dt plus 2x plus y is equals to 0. An initial condition is given that x is equals to y is equals to 0 when t is equals to 0. Suppose Laplace transformation, as we have in this question two differentials like dx by dt and dy by dt. Suppose Laplace transformation of dx by dt is equals to L x bar is equals to x bar, and Laplace transformation of dy by dt is equals to y bar. Now operating Laplace transformation on both equation, you will get Laplace transformation of x bar 5 into Laplace transformation of x minus 2 into Laplace transformation of y is equals to Laplace transformation of t. Similarly, Laplace transformation of y bar plus 2 into Laplace transformation of x plus Laplace transformation of y is equals to Laplace transformation 0. Now, from equation, this is equation 1 and 2. Equation number 1 is Laplace transformation of x bar is what? First Laplace transformation of first derivative s into x bar minus x of 0. 5 plus 5 into Laplace transformation of x is what? That is 5x bar, and minus 2 into Laplace transformation of y is y bar. As we mentioned, this is earlier. This is and right hand side Laplace transformation of t is what? 1 upon s square. Similarly, Laplace transformation of y dash is what? First derivative. Laplace transformation of y dash is s into y bar, and Laplace transformation Laplace transformation of first derivative s into y bar minus y of 0, and Laplace transformation of 2 into x is equals to 2 into x bar plus Laplace transformation of y is equals to y bar is equals to Laplace transformation of 0, that is equals to 0. Now question is y0. Now put the value of the initial condition. X0 is given that 0 and y0 is equals to 0. That means x0 and y0 is removed here. Now equation can be converted in this form. Take this part and this separately. S plus 5 into x bar and minus 2 y bar is equals to 1 upon s bar. And in this by this part 2x bar plus, separate this part first and last, s plus 1 into y bar is equals to 0. Now we have two equation and two unknown, x bar and y bar, and solve this to find the coefficient of to find the value of x bar. We have to remove this y bar, multiply s plus 1 in equation number 1 and minus 2 in equation number 2, and then add. You will get the value of x bar is s plus 1 upon s square plus s plus 3 whole square. And to find the value of y bar, multiply s plus 5 in equation number 2 and 2 in equation number x bar, 2 in equation number 1, and then subtract. You will get the value of y bar as minus 2 upon s square into s plus 3 whole square. Now the same problem here. We have to find the value of x and value of y. To as x bar is x plus 1 upon s square is s plus 3 whole square, and x bar is mentioned earlier. This is equals to Laplace transformation of s upon s square s plus 3 whole square. Now operating L inverse on both sides. This implies x is equals to L inverse of s plus 1 upon s square s plus 3 whole square. Now the problem is to find the inverse transformation of this, and you can solve this question with the help of partial fraction. Separate this part into single part and then take the inverse transformation of that, and you will get the value of x. Similarly, same procedure for y also. Okay. Some other important function is also here whose transformation also we have to discuss. First is unit step function. What is unit step function? The graph is of the unit function is given here. The value of the unit step function is defined as ut minus a, then value of this function is always be equals to 0 when t is less than 0 and equals to 1 when t is greater or equals to a. Okay. Now Laplace transformation of this function manually, 0 to infinity e raised to power minus st ut minus a dt. As the interval is break less than a and greater than a, that we can break this into integration 0 to infinity like this, 0 to a and a to infinity. From 0 to a, the value of unit step function is always be 0 as defined, and a to infinity, the value of the unit step function is equals to 1. So this integrand is equals to 0, and after solving this integration we will get e raised to power minus as upon s. That means Laplace transformation of the unit step function, which is defined over a, is equals to e raised to power as upon s. Similarly, unit impulse function, periodic function, Bessel function, error function, whose Laplace transformation is given here, and we will discuss this concept on Zoom class. Okay.